Okay, so let's have a look at the next question. Question 1.3. We want to show that this language here, strings of A's and then B's and then C's, such that there's a different amount of A's and B's, or there's a different amount of B's and C's, is a context-free language. And the trick we're going to abuse here is we're going to use the fact that it's relatively easy to deal with languages that have an or in it, because we just construct each of these languages separately, and then we can join them together afterwards, because we know that we can always union two languages by sort of adding a new starting state and then picking either one, right? So I'm going to design just this one first. So we want to design the language A to the I, B to the J, C to the K, where I is not equal to J. So let's work on that first. So here's my starting state. What can I do? I'm going to have something to generate different amounts of A's and B's, and then I'll have something to just pump out arbitrary many C's. So C can just make as many C's as I want. This lowercase c is a character, this uppercase C is a non-terminal, so don't get them confused. And then I need to make the same number of A's and different number of A's and B's. So how do I do that? I'll start off by making the same number of A's and B's as many times as I want, and then afterwards I have to put at least one extra A on the front, and then as many A's as I want, or at least one extra B on the end, and then as many more B's as I want. So A will just like make arbitrarily many A's, and then B will make arbitrarily many B's. Okay, so that's our grammar for this first constraint. Let's make a grammar for the second constraint. So A to the I, B to the J, C to the K, where J is not K. Okay, so how are we going to do that? Well, it's going to be the same trick as before, right? So I get my starting state. Okay, so I can make arbitrarily many A's. So where this A is, I'm stealing this A over here, use the same A. And then I'll call another letter, U. And this U will make the same number of B's and C's. So U will make matched B's and C's. And then afterwards, it either has to add an extra B on the front, and then arbitrarily many B's, or an extra C on the end, and then arbitrarily many C's. So I can again use these non-terminals over here. And then all I got to do to get either one of these is I make a new start state that can either choose the S1 path, or it can choose the S2 path. And so because we've created a grammar for this language, this demonstrates it is a context-free language.